Okay, let's talk about two of the biggest heavy hitters in technology right now, artificial intelligence and quantum computing. I mean, on their own, they are total game changers. But what happens when they team up? Well, that's when things get really interesting.
So, here's a thought. What if the very thing that makes quantum computing so incredibly hard, its complexity, its insane fragility, is actually the perfect job for AI? That's the big idea we're going to unpack today. We're looking at how AI is stepping in to become the key that could finally unlock the quantum future.
All right, so let's start at the beginning. Why are these two fields such a perfect match? It might seem a little unexpected, but it actually makes a ton of sense.
First, just a quick reminder. Quantum computing isn't just about making a faster laptop. Not at all. It's a completely different way of thinking about computation. It uses the totally bizarre rules of quantum mechanics to solve problems that would take our current supercomputers literally billions of years to figure out. But, and this is a huge but, building one of these things is insanely difficult. The early devices we have now are called noisy for a reason. They're full of errors. And getting to the real prize, these large-scale, fault-tolerant machines that can fix their own mistakes, well, that's one of the biggest engineering challenges humanity has ever faced.
And this is exactly where AI enters the picture. And look, when we say AI, we're not talking about some simple algorithm. We're talking about the whole sophisticated toolbox you see here. Everything from machine learning to the generative AI that's behind stuff like ChatGPT. This is the kind of advanced brainpower being sent in to help tame the quantum world.
To really get how AI is helping, it's useful to think about the whole process like a super complex futuristic assembly line. And every single stop on this line is a massive challenge in itself.
This diagram right here, this is basically our roadmap. It shows the whole journey, right from designing the physical hardware to running the algorithm, controlling the machine, fixing all the errors, and finally getting a result. We're going to walk down this line, step by step, and see how AI is becoming this essential co-pilot for the scientists and engineers doing this work.
So, let's start at the very beginning of our assembly line, actually designing and controlling the quantum hardware itself. Just take a look at this. On the left, you've got all these different types of quantum chips, and each one is its own unique, complicated beast. And then on the right, you see the process for getting them to work. It's this constant, delicate dance of sending signals, measuring what happens, and tweaking everything just right. This can take a team of PhD physicists weeks of painstaking manual labor just to get one chip calibrated.
But AI can automate this whole thing, and the process is actually pretty elegant. First, you have an AI model just watch. It learns all the unique quirks of a specific quantum device. Then, using what it learned, it figures out the absolute best signals to send to it. And finally, it checks the results and learns from them, getting smarter each time. It's like having a world-class physicist who works 24/7, never gets tired, and learns faster than any human ever could.
And this is where it gets really wild. AI isn't just tuning the hardware we've already built. It's becoming an architect. Because it understands the deep physics so well, the AI can start suggesting completely new designs for quantum chips. Designs that could be way more powerful or stable than anything a human might come up with.
Okay, next stop on the assembly line, we're moving to what is maybe quantum computing's biggest weakness, its Achilles heel, all those pesky errors. See, quantum states are unbelievably fragile. I mean, the tiniest little thing, a stray bit of heat, a microscopic vibration, can cause an error and just wreck the whole calculation. So we have this idea called quantum error correction, or QEC. Think of it like a superpowered autocorrect that has to fix mistakes on the fly, and it is absolutely essential if we're ever going to build a machine we can actually rely on.
Now, the brain that does the correcting is called a decoder. Its job is to spot the error and figure out how to fix it. The old-school decoders, they're fast, sure, but they're rigid. They're built assuming noise is simple and predictable. But AI-powered decoders? They're different. It might take longer to train them, but they learn from the actual messy, chaotic noise that's happening on a real chip. That makes them way more adaptive and way more effective.
And check this out. This shows just how powerful this is. What you're looking at is a transformer model. Yep, the same fundamental AI architecture that powers ChatGPT, acting as a quantum error detective. Its incredible knack for recognizing patterns is perfect for spotting the subtle signs of a quantum error and figuring out the exact fix.
So our AI co-pilot has helped design the hardware, and now it's zapping errors in real time. Which brings us to the end of our assembly line. What does the final product, the fully operational system, actually look like?
The end goal here isn't just a quantum computer sitting by itself. The vision is a hybrid system. The source material calls it an accelerated quantum supercomputer. And what that means is a deep, seamless integration where quantum processors and classical AI supercomputers are constantly talking to each other, working together, with each one playing to its own strengths.
And this partnership is only going to get deeper. I mean, we're talking about a future where AI co-pilots are helping people write quantum code, where AI simulations are creating perfect data to train even smarter AIs, and this is the most exciting part, where AI might even help us discover brand new quantum algorithms we haven't even dreamed of yet.
So, from designing the very first chip, to fixing errors in the middle of a calculation, and even to dreaming up the next big breakthrough, AI is truly becoming the catalyst for the quantum revolution. This partnership is really just getting started. So the only real question left is, what's the first world-changing problem, from discovering new medicines to inventing new materials, that you hope they solve together?